I'm going to evaluate all submissions one by one in alphabetical order, and I'll be giving the grades in this Excel sheet. Now, to evaluate robustness, I'm going to test all submissions on this other footage of a blue marker in front of the camera. It's quite different than the pendulum from previously, but there are some similarities, right? So, a tough one, but let's see how things go. I think the interface looks nice and it's definitely original. And the efficiency is okay, but it looks sometimes like these particles are moving in a jagged way. It might have to do with how efficient Python updates interfaces. I think JavaScript is more efficient at doing that. Let's see how it works with another footage. And it doesn't really work. The main reason is that my hand is in the screen, and the way it detects the pointer or the ball or whatever is by looking at how dark the pixels are. I've made a separate version of the marker footage, bright marker footage, where I'm emphasizing the top of the marker, and you can see it's better. It's actually much better, but it doesn't seem to detect anything above of this line here. And that's because of a piece of code that I assume is for optimization to make this run more efficient. And I've noticed it here only looking at the end part of the image. So this 300 tends to appear a lot later on, and I think they all relate to the same thing. I'm just going to extract it as an offset, and I will just say that I want to look at this as 0, so that it considers the entire image this time, because my marker is moving on the whole screen. And this is now not enough, because this 300 is appearing more and more, like here and here and here and here as well. Not very good code because of this hard-coded values everywhere. And now this is much more like what was intended. So yeah, this overall seems to work fine, but it did need some fine-tuning, so the robustness is not gonna be that great. It's definitely original, and let's have a brief look at the code quality even more. So not many functions. This while loop here is really long, and the code could be separated better. That's also one issue. And some of these variable names like index and M2, M1, 0.1, 0.3, 0.2, very difficult. Also some comments that are still there for some reason. Comments are not good. When you submit code for something, you shouldn't have any more comments there, unless they are just explaining what some blocks of code are doing, but even that can be avoided with good code structure and proper namings for functions and variables. So for efficiency, I'm going to give 7 out of 10. I think that it's quite good, even though it could be a little bit better. There were tries to make it better by focusing on the region, but that had damage on the robustness. So this, I'm just going to give 1 point. It did start to work after editing my input footage and changing some parameters there. I had to go in the code and figure out what things are. This is the weakest part of this submission, I think. Then originality, this I'm going to give quite high. I think that there is a lot of effort put into this. It's going to be an 8. Code quality, a little on the low side, so I'm going to give a 4 here. And the length of the string, this was reported in pixels here. I think that I maybe wasn't clear enough, but I meant the length of that string, the physical string, in centimeters or inches or whatever you use. Many people did get that right. So I'm going to be harsh here and say that no points for this. Even though you are calculating the length in pixels there, it's not what I asked for. Now, Asim has some issues here with the collisions. You can see the balls here are supposed to jump from the pendulum there, but they don't. And the idea is really nice, but it doesn't work as expected, and I promise to have a look and see what the issues are. So I started debugging, and first thing I did was I checked to see what is the pixel data that you actually extract. And I made a little bit different version of this function that also puts the image data where we mark the detected pixels as red. So main problem is you're trying to do too many things at once. You're trying to do physics, this detection, the collision detection, and all of these together can hide different errors. So start with the simpler things first, and debug each individual component well. So you see, these are marked as red here as well, not just the ball and also up here. But that's not the problem because these are bouncing from other regions as well. And question could be, is this collision somehow the problem? And I'm going to modify the code for doing this physics here. And if there is something that is collided, I'm not going to do all this fancy stuff. I'm just going to draw the ball and comment out this part from here, and then set the velocity of the ball to 0. So all I want to do is have the ball stop at this moment and see if that works. But only if there is a collision here. So I still need this if statement, like so. Now the balls are dropping here, and at some point some of them just stop in the air. So the problem is not here, it's somehow detecting this collision. And this is collided function is having some commented code here. I'm not going to look at it. And here it's doing something relatively complex. It's looking at the pixel values and it sees if this is a valid color that is also inside of the circle of the ball that is passed here. Very complicated stuff. Simplifying this complex logic would be to just look at the middle of the balls and see if they overlap with those red pixels. So let's just worry about that. Maybe here in circle and is valid color have issues. So I'm going to look if is valid color for capital X and Y, the parameters there. And if this is the case, I return X and Y like this. Seems to be the same problems. So not an issue here, but now this is much simpler because it only looks at the middle point of the ball and I don't need to worry about in circle, for example, having problems. So the issue might be inside of this is valid color, and it took me a while to figure it out. Problem is here, and there are many problems with this code. Things that to you are clear, but to others are not. Like, what is this place and what is this calculation doing? And if you're familiar with these things, then you do know that this kind of resembles how you transform the long array of the image data into an XY coordinate and vice versa. But the problem is that a multiplication by 4 is missing here. And it is clear to you why that multiplication is missing, but to me it took a long time to figure out. And the reason is that your pixels are defined here so that you jump by 4 and you add a new item in it. So one pixel represents 4 values from that image data, and then not multiplying by 4 there makes sense. But your formula is wrong. So it looks good, at the first glance, and I was thinking, what is the problem here? And I spent a lot of time with it. The issue is that x and y are pixel values and they can't be floating point numbers. But your location of the ball can be a floating point number because of the physics and how you make it move. It could be 1.75 or something. And that is the issue. You are rounding, but you're rounding too late. This 0.75 there multiplied by the width is going to offset things around a lot, and the calculation doesn't work as expected. So what you want to round here is the y multiplied by that plus x. We don't need the parentheses here. So no more issue there. And now when falling on the red area, you can see how they stick exactly where they need to stick. Hope this helps. Re-enabling some of the physics may make some things to work again, but not great. You still have many things to polish here. Let's see what happens with the marker. So not detected well. The tip of the marker is detected and also the hand is detected. It's the same thing that happened previously with Anandu. It does work better if we do the bright. In that case, this really becomes very well defined there. So the robustness also has a little bit of issues if you think about application working eventually. Efficiency, there is a lot of things that can be improved here. When you're calculating these pixels, they don't really need to store all the versions that are not blue. Too much memory used for nothing. You're only interested in those pixels that have a blue color, and you don't use the others in any other way. So you're storing here all the pixels for nothing, basically. And you don't use any of these RGB values afterwards either. What would be more useful is to keep here just the pixels that are blue and maybe keep their coordinates instead. Maybe even storing them as a sparse matrix or something. But anyway, there is a lot of wasted resources here. So not very good from efficiency point of view, and robustness also needs work. Originality, I think the idea is really good. So you're gonna get 8 as well. And code quality, there are several problems in this code. Few of them I did point out, but there are several things that make this difficult to read, like the comments I already mentioned there, and 2 different blue color, what does it mean, and things like that. So 4 here as well, and I haven't seen effort in predicting how long the string is. This is really nice, and it works quite fast and smooth animation. Let's see what happens with the other footage. And I didn't need to do anything, and it just magically works. So very robust as well, very original. And code quality, there are some of these commented out pieces of code. I really recommend removing them. And the code does use some things from another library. So not all the code for achieving this is part of this package. That's not the bad thing. I think that this Voronoi implementation is okay to use. I've used it a lot during my years, my experience, and I've never implemented it myself. So it's fantastic to use, but some of this code is not yours, and because of that, I'm going to say that you coded less than what the application is doing. So less code compared to other people when I do the evaluation. And here, very clear section at the top with the parameters, and again, commented out pieces of code that are just confusing, nothing else. And also, some of the functions are quite long. Like this animate function is really, really huge. It does have sections, what you're doing here and there, but you could have functions that are extracted from those, and then the code would be easier to click. There is also some kind of optimization going on in different parts. So The distance is squared. It's not using the actual distance. And that means that it's a little bit more efficient because you don't call the square root. Few typos, like color math. I think this is probably color match, but it's fine. Sometimes when you code by yourself, you don't notice these kind of issues there. So efficiency, really good. I'm going to say here a 10. Then robustness, this worked with no problems. I'm just going to give this a 10. Originality, I'm going to give this a 9. Using Voronoi is a special thing, but I have seen many effects using Voronoi, so not 100%. And I did give a little bit extra because there is this kind of special effect that you add to Voronoi. So it's this lighting up of those cells there. So that's nice work. And then code quality could be better. I think that those comments I made make sense. And I'm going to put here a 7. No attempt to figure out the length of the string. Really nice smoky effect going on here. Let's see what happens with the other footage. And it just works. Now the code is good. It's divided into multiple files to do many different things. And I think that the structure is one of the best. You have constants extracted there. You have comments explaining what the things are. Utility functions here. Operating the video. This hook. And then the ball detector is here. And the ball is here. I didn't quite get why these are called drops when it's the smoky kind of effect. I think to me it looks like smoke, but maybe I just missed something. Some small issues with indentation here and there, and makes it a little bit hard to read with just one indent there, at least for me. And sometimes the logic is a little bit complicated. I'm not sure what happens in some of these cases. Working with queues, reversing queues here, this probably just means removing objects from the scene when there are too many, because here you're filtering based on the time, so you keep the minimum ones. And some of this code here is a little bit too much, so there are some functions here that don't make much sense, like what does this really do? And I had to comment out things and figure out what is happening. Like if you don't keep this one here, you don't get that smoke effect, but you do get just the kind of shadowy, fast moving balls there that are on top of the marker. Now, one thing that made no sense to me is, where is it? Here. There is some formula that you use to get the length of the string. But here you're doing some fishy things. I'm not sure what this is. Subtracting a percentage of the hook length divided by the length in pixels. Something weird. Looks like some kind of adjustment that I can't figure out why it's there. Maybe it's how far the anchor point of the pendulum is, or something like that. I just couldn't figure it out. And the estimate is 110 centimeters, 120 centimeters, so somewhere between those. It's a little bit of an overestimate. And yeah, not bad, but a little bit of an overestimate. So you will get some points for that. Efficiency works pretty well, I think. I'm going to give this a 10. Robustness worked with the different footage. I'm going to give you a 10. Originality, I think it was original. I'm going to give you a 9 as well. And code quality, there are some things that can be improved, but a lot of things that you do right as well. So I'm going to give you a 7 as well. And here the length is going to be some points for that. I'm going to give you maybe 5, and then let's see how people get closer to the true value compared to your baseline that we have here now. Banana Man has the most worked on application, I think. I've seen it in the early stages and I noticed the updates. There are even instructions here, what it tries to do, what it does, and how to run it. Let's start with this initial footage I gave you to test and run. It's a very scientific submission. You can see a lot of charts here, a lot of debugging lines here, trying to figure out where the attachment is, this hook located, calculating different properties like these amplitudes, angles, speeds, and so on. There's then this estimate button here. And after that, you get a lot of different statistics appearing here. And one thing that I want to really point out is that there is a calculation for how big the radius is here. It doesn't look quite right because I messed with these parameters, default parameters that were given with the application. Let's try again. Now it's better. You can see that this ball is very well surrounded by this bounding box here. And the statistics are going to change when we estimate them at the end. Okay, and here you can see now this is the length that I was looking for. Many of you were actually calculating the length to the center of the ball, like this. But that's not the length of the string. The string wasn't going to the center of the ball. It was starting here at the end of the ball. So here Banana Man is also taking that into consideration, the radius. And this is really correct. Like the length of that string is 97 centimeters. So a little bit overestimating here. And it's the best estimation here and the only one that considers also the size of the ball here, even though the physics don't require it. But knowing the length of the string is what I asked for, not the distance to the center of mass of the bulb. So let's just add here maximum points for detecting the length there. Then code quality is really good. I'm gonna give this a 9. I could give this a 10 with no problems, but there is something about the interface that I don't like. So if we change some of the properties in the interface here, like for example, this minimum and maximum values of the hue, they don't affect unless we save the values. So now if I stop the video and rerun this, these are going to be reset as they were previously. And I don't think that a save button here is necessary. It's not so much of a comment about the code quality, but about the interface in general. And you wouldn't think that this is really a problem. You see these moving around. But if I'm going to try to load another video, like the one with the marker footage here, then this one ends really, really quickly. And you can see it doesn't work well by default. So there's something to say about the robustness. And the problem is, if I want to fix this, it already disabled the interface and I can't press save and I can't move the things anymore in this case. So I'm trying to get this to work And I think I did something. Let's try again. It's something, but it's still not perfect. And I have to move really, really quickly. So somehow the attempt to make this really, really efficient, yeah. Okay, I think I got it. But I have to run this again and save quickly. Okay. And now I think it looks good. Almost good. Sometimes it's disappearing, I think. So I still need to work a little bit with these sliders. So going back here, the robustness, it's not perfect, but the sliders let me do the things that are needed to make this work. I know because I've tried previously and I got it to work. That's why the settings I had weren't the default ones. But there is extra work for the user. And combined with that code quality issue, which is not really code related, but related to the user interface, I'm going to give here a 7 points for this robustness. Originality, to make this into a scientific application like that, analyzing these harmonic movements is fantastic. So I'm going to give this a 10, even though it's not creative in the sense that no fireworks flying around. It's really original and very complex. So I recommend anybody who is interested in these kind of scientific analyses to have a look at this code. Then the efficiency is out of this world. The videos even go faster than they should go, and that's the reason why I spotted these issues with the interface is not updating properly and causing confusion to the users. So really high efficiency here as well. Let's look a little bit at the code. So it's Python, and there are instructions, clear instructions how to set this up, and the functions are really well written. Everything is really short and to the point. Comments explaining what the blocks of code are doing. Sometimes Python doesn't use functions as much as in other programming languages, but it's okay when you group things together in blocks. And many different sample videos. So here we get videos where the image is rotated, the image has different hues. There is a lot of testing here involved and trying to make this application as robust as possible. Utility functions here really well explained and documented. Constants well defined, and then the values are loaded from the files there. And I don't want to make this video just about this code, so I won't go into details here, but do have a look at the blog post and all the explanations and all the care that has went into making this, because this is clearly, easily the most worked on application submitted to the competition. This is a really funny one. It's one of my favorites. I think it's great that you managed to map the movement of this character with the pendulum there. Really artistic choices here with the movement of the eyes and the nose and everything. And let's see how it looks like also with the other footage. By the way, I modified the code a little bit so I can test here and not on CodePen. It's faster. So now you can actually tell that the nose is following vertically and the eyes are following horizontally. And when the marker is not there, you get to see the back of the pig, which is great, I think. Back to the original footage. You see here some estimation also appears for the length of the string, and it's similar in quality to the one we had before, Banana Man's very robust one. So same as Gokhan there. And I'm just going to put the same value. Efficiency is a 10 in this case. Now, robustness worked in both cases as well. So I'm going to put here a 10. And then originality, it's really original, I think. So I'm going to give this a 10. And the code quality, let's have a look. I have a fetch here starting the video and then the animation sequence. Some things are a little bit confusing, like two contexts for drawing, and this function is really, really, really long, and it does have this part where you're starting to say what are you drawing exactly, but there are parts here where you just calculate things, so figuring out what to draw and drawing could be separated, definitely. And then maybe some object-oriented programming could be used here to make the pig as an object. It makes sense for it to have those properties, not just calculate these on the fly like this. And you're using values like the height of the video to determine how the eye looks like. You want to have a function that takes a parameter, how big the eye should be, and then that parameter is easy to read and to know what is happening here. Looking at this code, you won't be able to understand anymore what is going on here after a few months. But if all you get here is an ellipse in the center of the eye location and then radius of the eye as two parameters, it's so easy to read. And then when calling that function, maybe there is the math going on, but drawing becomes really clear as a result of good parameter naming and not just passing these things here. Sorry, but yeah, I'm gonna have to give a low grade for this code quality because of that. It's really, really bad, even though it works, and even though it's really clear for you right now, it's very difficult for other people to understand. Here we actually have a Zim.js application, and it's something made for kids, inspired by the video that I posted. So it's not exactly what I asked, but let's see how it goes. And there are many different applications, in fact. So first one is this one, where we have a pendulum that looks pretty much like what I asked for. And then there is a fishing game here, and it actually works with the camera. And I'm not sure if I'm using the correct camera. Now the camera works, and it's using the front camera from my laptop. So you have to do this fishing, and you move your hand. It's doing hand tracking, and then you have to... I'm not exactly sure how to get this to work properly. It should somehow pinch, but doesn't seem to work well in my case. Anyway, there is some kind of interaction going here, and it's definitely very much working, moving the hand at least. Next one also uses the camera, and I think this one uses the color. I'm adding the marker now, and you can see me a little bit in the background there. The camera is faded. This color sensitivity is something that can be also tuned there, but it seems to work with a long lag, so the thing doesn't move really in real time. The drawing catches up to the movement of my marker as I'm moving it, so it takes a while for it to react. I think this is somehow on purpose to make this look smooth, and so that you don't get dots separated somehow. But anyway, and then I think some more creative examples here, really fitting for the kids, where you have the monkeys pushing this pendulum and some other similar things. This one more abstract here. The efficiency, I'm going to say that some of these things feel a little bit sluggish, so I'm going to give this 7 here. The robustness, this seems to work in some situations and doesn't work in some other situations. So sometimes this camera movement with the hand was okay, but not totally working. I'm going to give this a 4 here for the robustness. Definitely very original things I've seen here. And the code quality, I can't really comment much about it. I've opened some of these pages like this and had a look in this kind of view here, and I've noticed some issues, like some things being not indented properly, or some things being very long lines like this that I don't know exactly what they mean, like hard-coded values there. I want to say a 6, but again, I'm not confident about grading this part from here. And no attempt for making the guess on how long this string is. Zim.js looks like a really nice platform for making some creative applications, especially nice for kids. Now, this starts off a little bit boring, but ta-da! Really cool. I really like how this looks like. Especially because this is not the 3D item here. It's actually made from very many different images rotated at different angles with some transparency there. And there is some math here for figuring out where he should hang from, and also the background images here. So really interesting, very creative, original submission here. Let's see what happens with the marker footage. And nothing happens. And the reason is that it needs to have some kind of certainty for Spider-Man to appear. So let me try to remember where that was. Here, something to do with this error. Yeah, so this center here, this count equal to 1, this is kind of a true condition here. This needs to be true for drawing the image to happen. So I'm just going to open the developer tools here, restart the video, and set this to true manually like that. And now you're gonna see this going on, and it's so great. Like it really reminds me of motion capture and how 3D movies are made nowadays. Like, if you want to have real footage and animate it in a realistic way, like how the thing in the footage looks like, this is how you do it. And sure, in this case, it's just one tracking point, but you can have more. And even one is really enough for getting something really nice here. So I really, really like this submission. Now, let's see. Efficiency here, really well. I haven't noticed any problem. Robustness worked in both cases with no issue. Originality, definitely gonna get maximum points. Code quality will look in just a second, but the length here, let's see, was there an attempt to measure the length? Because there was. And it's not fantastic. I think that many people who have made this calculation assumed the distance from here to the center of the ball, not the length of the string. But all of them end up in the same category, pretty much. Now, the code quality. There are here some clear instructions also what to do to get more. Features there, like you can put here true to these, and running again is going to give us a little bit more things to work with, like this graph here appearing, this chart, which is very similar to what Banana Man was doing there, and also a little bit more debugging here with these points, and those are used to calculate that error and actually show Spider-Man. At some point he also says something at the end of the video, how easy it is for spiders to calculate the distance, and now you can see that this location here is actually the middle of that ball, so it's not the top of the ball for calculating the proper length of the string. Let's go on with the code quality. I have to say it's really good. Only thing bugging me is comments that are left there, but other than that, and some variable names that are not very well chosen, but they are somehow explained with the comments around them. And there is a lot behind this project as well. There's a lot of science that went behind this, similar as what Banana Man did, but the interface doesn't really show it unless you add those debugging values there. So overall, the code quality here, I'm going to give a high value. I'm going to give something like an 8, because there are some issues, some things that could be improved a little bit more and a bit less misleading. This is a really dynamic effect. Looks like it's on fire. Let's see also how it looks with the marker. Not like much. So the robustness is something that is an issue here. Notice that in this detect ball, if we replace these values here with 60 and 80, we are able to get something out of this. But it's a little bit different than before. The canvas is not cleared between each frame because there is no support in the new image. And this is really taking into consideration many things here at the top, like the color of the ball, the color of the hand, and the color of the support. So it's really doing a lot of image processing to figure out some things there. Quite much work, even though the result looks maybe simple apart from the fire animation. But if you look closely, you will see that it does a lot of things. It's just small fine tuning, and you have to be careful to see that my hand does appear there in the new rendered video and so on. But where was I? This center of ball and center of support, clear rect can go before these. And even if you don't have this part of the code, it's not going to matter in this example. It's going to look as expected. And with the changes in those thresholds, this does look good, just as I hoped for. One thing that we still can talk about is the code efficiency, and I've noticed some problems here. For example, in this fire particle, you're updating here the velocity on X and the velocity on Y, but you're calling all these vector operations like subtraction, normalization, scaling, and then taking out the X and then taking out the Y. But you're doing all these calculations twice, essentially. So really what you want to do in this case is, well, you don't want the Vx and the Vy, you just want the V. And just keep there without the X. What is the result from there? And now let's fix this everywhere. So Vx also in the constructor, the same problem here, really. You don't want the X from there, just keep the V. And then let's look again for this Vx. To get the velocity, the getter for the class here, we just return this v, like so. And set the velocity, this v is equal to the parameter. And I think we're done. If we did everything correctly, everything should still work, but now it's twice as efficient pretty much, because you're only doing those things once and not twice. The efficiency can use some work, and I'm going to give here a 6. Then the robustness, it needed some help from me. I'm going to give a 7. Originality, this is really original, I think, and I really like the effect at the end, and you paid a lot of attention to small details there. So I'm going to give this 10. Code quality, there are different problems here and there, and I already pointed out some of the issues, but comments and indentation problems from time to time, some hard-coded values that are not really explained. Why do these have to be there and how to choose them? It took me a lot of time to get this to work with the new footage. But that's because the code quality was bad, not because it wasn't robust. So I'm going to give this a 7. And there is a calculation here for the length of the string. Turns out to be 0.784, which is an underestimate this time. The time period is not correct. I tried doing what you say here, counting how many times the ball goes between 3 and 21, and it doesn't swing 10 times. I think it swings 10 times when you count until 24, if I remember right. I'm not gonna do that now, but there is some mistake in this calculation, and again, you're not accounting for the size of the ball. So some mistake there. I'm still gonna give you a 5 in this case. I think it's similar effort as the others. Now, when seeing this, I have one big question. What is this point doing there? And how does it align so well with that frame in the original image? It looks crazy. And I kind of like it. I mean, it's making me confused, and maybe it's supposed to be part of the actual effect. But the effect itself is really nice, and it has many particles, and here's some information about it, some statistics, and quite impressive particle count. Looks good and feels very smooth, very efficient. Let's see what happens also when changing the footage. It works pretty well. And again, questions, what is this support doing there? It looks very crazy somehow. Now, efficiency is pretty good. I'm gonna give this a 10. And robustness, it worked in both cases. I'm gonna give this a 10. Originality, I think the effect looks really good. I'm gonna give this a 10, and we've seen similar things implemented and they work, and I like how it looks like. Then the code quality and the length. This is where we need to have some look into. When drawing that support, this is what happens. It's moving on the x a fraction of the y value. So this is nonsense. That's the reason why we see that weird behavior there. I'm not sure what it's trying to achieve, but it definitely doesn't do a very good job there. Or it does make me interested in how this works, and it looks kind of cool, but it's not what it's supposed to do. And it also returns the result in pixels. So this is the hypotenuse where you consider some fixed support point, I think. Anyway, there are commented pieces of code here and there. And the variable names are decent, and the code is definitely readable. Split into different files. It's not bad. this color math issue here as well. I think that it's possible that you're using some of my code bases and maybe I made the typo. Oops. It's possible. Yeah, but the length just in pixels and the code quality okay-ish. I'm going to put here an 8, and because this is not a proper answer to the question, I'm gonna put a 0 there. Now, this application makes you see the ball better by changing its color to different colors from this selection box there at the top. And I think it's doing what it's supposed to be doing. It also emphasizes this here, so it's not really detecting the ball itself, but detecting dark pixels, I think. And the center of the ball is something that I found here in the comments that tried to do to detect, but was unable to figure it out. I think that studying the other code bases that were submitted here, you should have no problem figuring out how to do it. I won't go into the details here. But this does what it's supposed to do. And let's see also the marker footage. And yeah, it does emphasize also part of my hand. So I expect this is not what you want to get in this interface. So efficiency, it's really fast at doing what it does. Robustness, it's not perfect. I'm gonna give this 5 because in both cases, even in the original material, you couldn't isolate exactly the ball pixels there or close to that. It was clearly that part of the image was also considered there. Originality, I think that this is quite original and even helpful, so I'm gonna give this maximum points there. And code quality, it's not fantastic. It's small piece of code, and you have here functions like red, green, blue that don't really work in a proper way. I mean, they are the same thing, but setting different values to this global object. And then you have naming conventions that are a little bit messed up, like capital letters here compared to lowercase letter here for the function names. And the code isn't doing very much, but it's a little bit too much than it would need to be to accomplish the same problem. So these functions should be just one function, set color, and then the color is a parameter or something like that. Otherwise, it's not as complex as the other codes that have been submitted. It's probably the easiest effect to implement here. So I'm going to have to consider that as well when giving the grade here. And I'm going to give this 4 here. And there was no attempt made to estimate how long the string is. Now, this is an interesting one. It displays a clock there, and this is the actual time. The length here is really, really overestimating it. And the effect is not just displaying the line here and the ball a different color, but also making this pendulum go on forever, seemingly. So some manipulation here where the video starts and where it ends. These values could be tweaked a little bit, and the interval here, it jumps over a few frames, so some weird behavior is happening. I would integrate this with the animation loop and measure a frame count or something instead. But it does something reasonable, and this pendulum does look like it resets from time to time and gets an extra push, so to speak. So it's nice. One remark was that there was an attempt to make this second hand here synchronize with the pendulum there. And it didn't quite work out. And I'm not sure if I'm going to be able to answer this because I'm a little bit in a rush now, but let's see. Let's also check what happens with the marker footage. So seems like it's recognized properly and that line is being drawn properly, and it even loops in an interesting way forever. So kind of a lucky there. But let's go back to the original footage and see, can we get this second to actually go according to this thing there, according to how the pendulum moves. So in app.js, the seconds are calculated based on the time and the current values here. So instead, I'm going to take this out and have them as a global value. I'm not going to worry about code structure much in this one. And maybe define them here. Let seconds is equal to 0. So now this second bar doesn't move at all. Now getting the location of the ball and then the center of the ball. Here we could use the old location of the center and see if there is a difference. So maybe we just check to see if the new center is going to be to the right of the old center and see if we can increase the seconds based on that and what might happen. So let's try here, check if old center exists. And if there is, let's get the sign of the difference on X. Like so. And also keep message. Let's first just increase the seconds based on that. So seconds plus equal that sign. Now old center also needs to update here based on this center, and by default it's null. Let's see what we get. Seems like something crazy going on. Let's debug what these seconds are. Aha, they become not a number really quickly. Ball is missing there, not in the screen. Still a problem. Oh, if it's not a number, yeah. So not what you expect. But we could control this even more. Like maybe we could say here, if sign is positive, then increase only the seconds in that case. And now the seconds increase only when the pendulum is moving to the left, which is some interesting behavior. Not exactly what you expect probably, but something. Something that the pendulum controls this second hand and it makes it unique. Now, we could try to figure out what we really want here, and that might be when the sign changes. So maybe we keep a measure of the old sign, like this, and here we check if old sign is not the sign. Then we increase the value by 1, actually. Let's see what happens now. Aha, old sign is not defined because I haven't. Let's just say it's 1 by default. So now this is actually doing exactly what we expect, but a little bit strange artifacts here when the video resets. I think it's jumping 2 seconds there. You may need to filter that, make sure that it really starts at the same frame again. Also, looking where the sign changes means we are focusing on this part of the video where the ball is moving slowly. And when it moves slowly, it might change also because of the image processing. So maybe it's better to look where the ball is moving fast at the bottom. And there you would use the speed of the ball. So that's going to be maximum when moving in the horizontal, in the middle part. It's going to be the fastest. It's also going to be the point where the acceleration is changing because it speeds up until that point and then it slows down because gravity pulls it back after that point. So maybe looking for acceleration changes instead of these patchy sign things I'm doing is a more robust approach. But yeah, efficiency, this seems to work pretty well. A little bit glitchy because of this not exactly there where I want this to reset. So it gives an impression of lag, I think. And I'm going to give this an 8. Robustness, this worked pretty well in both cases. I'm going to give this a 10. Originality, this is quite original that you want to incorporate the clock somehow as well, and I'm going to give this a 10. Code quality is actually quite good. You don't have many problems in the code, very few hard-coded values, but the code is not doing exactly what you have wanted it to do. So I'm going to give you some penalty here because of that. And estimating the length, here you have a huge overestimation because you think that t is 3 seconds. It's more like 2 point something. So I'm not sure how you ended up at 3 seconds, maybe just looking at those intervals that you wanted to reset the video, but there is some error in measuring that. And really, to get a good estimate, you have to look multiple times and then divide by the number of times that it looped back. So 3 is very different than 2, and it will give you the impression that this pendulum is 2 and something meters long, even though it's around 1 meter. Last but not least, this crazy thing. I'm clicking to fire at the asteroids, and the spaceship is moving according to the pendulum, obviously. And I'm trying to not get hit by the asteroids and hit this big one here in the middle, and oh, it's not as easy as you might think. I also have to defeat the other one before the time runs out. I won. I think I won. It disappeared quickly there. Maybe through the magic of video editing, I could pause that frame and demonstrate. Now, changing this footage to marker footage. It becomes actually very difficult. So now the marker is moving. It's very close to the other asteroids. It's smashing me into them. And it's like this hard code level, and it even ends quicker than the other one. So I'm not able to finish the level, or basically I lose the level because I'm not able to win in that shorter time. The video is shorter. Let's have a look at the grading here. So efficiency, really fast, 10. Robustness, worked in both cases, 10. Originality, 10. Code quality and the length. The length, I didn't see anything about that. I hope I didn't miss anything. I don't think there is any attempt to estimate the length. The code quality is really good. It's a big project. It's making a game here, and I don't really have complaints with this. There might be few issues like that end screen going too quickly, and I don't have the possibility to look at it. But look at this. This is really well made, well polished. No bad issues like with indentation or naming. Comments were needed. Functions are relatively small. Objects were needed. It looks good. And I want to give this good code quality, so it's going to be a 9. The reason I don't give any 10 is that I wouldn't give myself 10 to any of the projects I make. I mean, I could always improve something. It's important to know when to stop. So let's see what happens here. I'm going to add the formula for the sum, and let's sort this column. Look at that. We have Banana Man at the top, followed by Potato 11, and then Gokhan, Jorbington, Vic Thor, Pufikas, Bretto, Pritam, Sam, Rajver, Karel, Anandu, and Asim. In my opinion, all of you are winners. So I'm not going to draw any line here. If you want, you can make a video explaining how you did your solution, and I can host it on my channel, or I can promote it on your channel. Also, if you want your credits registered at Karelia University of Applied Sciences, contact me and I'm going to send you the registration form. See you guys.